let's create a new part. Let's call it Spiral Bevel Gear, Crown Gear 2L. Okay. Okay. All right, so we start again. We're going to go into model intent, go to relations, and we're going to be recopying these in and recopying in these diameters. Okay, so let's start off. I just want to have this next to me for reference. Shaft angle is going to equal 90. The module is 3. The pressure angle is 20. The mean spiral angle is 35. Z1 is 20 and Z2 is 40. Okay. Next, relations, parameters are there. Back here, all of this gets copied again, Control C, Control V, verify, and press OK. Okay, now we can go straight into build. I'm going to start by putting a center line here. I'm then going to draw, oh, you are wrong, a line, there you go, perpendicular, divide, and create another line. Excellent. Again, we're going to start by dimensioning delta 2, the face, and R. Excuse me. No, come on. Behave. There you go. R, face, delta 2. So go to Tools, Relations, SD6 in this instance is going to be the face, insert to relations, SD4 is going to equal delta 2, insert, and SD7 is R. Verify and accept. Okay. Same again. Let's just bring you down here. We need to do the addendum, dedendum, and the tip and root angles. Now, again, important, we're not using the same addendum and addendum as gear 1. We're using the unequal relations. So we've got to make sure we're copying in the right geometry here. So let's extend you out and you out arbitrarily. I'm going to divide here and here arbitrarily, and we're just going to put in, oh, we're just going to put in these, again, arbitrarily, because we'll be setting the relations. Okay, so I want to have you and you. I want you. And I want you. Okay, back to Tools, Relations. Let's start with the addendum, denoted by HA. So we want to find HA2. Notice how it's much smaller than HA1. Insert. SD19 is going to equal HF2, which is the addendum. Insert to relations. This here is obviously going to be the root angle, root angle 2, and this here is going to be tip angle 2. Verify and press OK. Excellent stuff. Notice how that addendum is so much smaller. Okay. One thing just to note, by the way, I know that we define all these angles through maths, but this line, if you'd extended it, the addendum from the tip circle and the addendum from the base circle, if you actually just extended these lines out, they do just, connect to the middle anyway. But good to have everything mathematically correct. Okay. So just as with the first gear, the steps are the same, just in slightly different orientations. So first off, let's revolve our surface that will end up projecting our tooth trajectory line onto. So project, U, press OK, press OK. Yes, I want you to be a surface, and revolve. OK. Next up, we're going to be sketching, and we're going to be sketching on this, which is the right sketch orientator view. Now again, I don't want to sketch this underneath, from an orientation underneath this cone. I want to sketch above, which means I need to reorientate our view to left. Okay, let's reference here, let's reference here, 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 here. Okay. And for reference, let's just bring in the calculator again, and let's look at sketch reference gear 2. Okay, so again, we're going to be sketching opposite to sketch 1, which was top left to bottom right. This is going to be bottom left to top right instead. Okay, so let's do this systematically. Snap, snap, point to denote the middle, and then it's top right to bottom left, bottom left to top right. So click on there through that point, snap to the end. Let's define the angle, go to tools, go to relations, SD1 is equal to the mean spiral angle. Verify. Okay. Next up, back to sketch. Extend a line, which is going to be perpendicular, just randomly into space. Don't let it snap to anything. If you want to just double check, just, that should be 90, and it is 90. I'm going to create a circle, which the center of which is going to be at the end of this newly created perpendicular line. Snap to that point, define this length, and in tools and relations, we want this to equal, it's towards the bottom, I believe. Yeah, the cutter radius. Verify. Okay. Okay. After this, the process is the same. I want to create a new line from the middle of the circle, snapping to the point at which the curve hits the outer part of this cone. There. Another, because these are so close to each other, be careful you don't accidentally snap the start of a point on here. Make sure it is the middle of the circle. Let's bring you out. Define this angle. You know what? I'm not going to set this in the relations. I'm just going to write this out. I'm going to have that be 65 as well. And then we're going to use the divide tool to split there and split there. Click on the large pi, and we're going to set that to construction mode, and then every other line except for the curve here also becomes a construction line. Great. All right, that there is the sketch. Let's just have a look. Bang on. Very good. You can see actually when I took the screenshot, I'd already made the conclusion I wanted to change this to 65 anyway. All right, very good. Right, let's press OK. So we have our curve, but we need to extend the radius, extend the surface cone here. So let's click on both of the edges, the upper edges of the cone, extend. And again, if I now go back to left, I just want to make sure that I drag this to be far enough that it covers and extends beyond the end of this curve. That's all. Press OK. Click on that curve, and let's project it there. Okay. Excellent. We are making progress. It looks like one of those football cones, doesn't it? You know, that you put out in fields. Okay. Right. Next up, we are going to, again, use the pattern tool to move a copy of this curve to be directly in line with our initial geometry here. So, but to do that, I need to understand the distances involved. Let's go back to a left orientation. Okay, so if I just drop a point there and drop a center line through that point and through here, I know that we need this to equal 7.99. Remember that value, everybody. Okay. Exit out of that sketch. Select that projected curve pattern. We're going to go for axis pattern. Choose, oh, excuse me, here. We want this to be an angle of 7.99, and we want there to be just two members of this. And I think we need to flip this, don't we? Yes, we do. And press OK. Excellent. Okay, and now our copied geometry, this curve that will be the trajectory of our tooth, is exactly where we want it to be. Okay, I'm going to go in and just hide the first, and I'm now going to hide this revolve. Excellent. Next steps, again, yeah, I'd want to save model, Control G, save. Next step, again, is we want to create the circles. These ones, we need the coordinate system, we need the plane, all of which we'll do right now. So first off, I'm just going to drop a point at the end. I'm going to create an axis through that point and running through this plane here, the front plane. Press OK. I'm going to create an axis, sorry, no, a coordinate system even. Click on that point. Orientation, we're going to use this line for the Y axis, the newly created axis for the X axis. And you press OK. All right. We can put an axis now through the Z here. I actually just use the Z-axis as our rotational axis in the previous model, but to make things easier, I'm just going to just drop another axis in there. Okay, save. Next up, we're going to create that plane. Okay, that cuts through this end line here. And we're going to sketch. First off, let's reference a few bits and bobs. I want to reference you, and you. Okay, orientate the view. And we're going to create 3 circles snapping to each of those points. Okay. Right, so if you remember at this stage in the previous gear, next up is the involute curve. We then create the profile of the tooth. We then actually use the swept blend tool to create the actual tooth itself. We pattern. We're getting very close. All right, so let's start by putting in the involute equation now that we have all of this stuff ready. So curve from equation, choose the newly created coordinate system, edit. Let's go back to our relations tab, and we want now gear 2 involute curve equation because we're now referencing D2, not D1. Very important. Okay, and perfect. Okay, again, this is too large to handle right now, so we are going to trim this with the tip circle being the cutting, the trimming object. Flip the arrow. We want to remove this. It's the highlighted in blue section that was removed. Press OK. So now we have this involute curve here. And what we are going to do is sketch on this plane, DTM1, orientate the view. Let's use references. Let's reference here, here, and here. Here, and here. Close. I want to hide that just for the moment. So we're out of the way. You don't matter too much. All right. Let's project the involute curve. Let's draw an arc from that involute curve in this direction. Let's dimension that arc. Again, end, hold control, end, middle button place. And let's relate that correctly to tooth. Normal tooth thickness, insert to relations, verify. Okay. And then we're going to drop a point in the middle of this arc, create a center line to the middle of this main circle. There we go. And then we're going to mirror the involute curve. Oh, select, mirror, and place. Okay, let's change this arc now to a construction mode arc, and let's finish the tooth profile. So let's cap the end there. Again, we're going to just extend this down to the middle and then reconnect on the other side. I'm going to create a new line here, but I want it to be parallel. Are you going to snap for me? No, you're not. Right, I'm just going to hold shift and just drag this out and place it arbitrarily. I'm going to use the parallel tool to have these parallel like that. Delete you, delete you. I want to set this to 8. Okay, that's our teeth profile. Press OK. And the same thing again, I want to pattern this sketch so that I can have it positioned here to be in line with our projected curve copy. So this is where I went wrong with the first one because I used the wrong rotational axis. We have to make sure we use the right one this time, won't we? So let's go back into this sketch. And I need the angle between the midpoint here and the y-axis, 1.86. Remember that value. Exit out of it. With a sketch selected, pattern. we're going to be using this axis here. So axis pattern, this axis. It's in the right direction already. We want two members. Oh, what was that value again? I just wrote it down 1.86. Enter and press OK. And first time this time, our tooth profile is copied in the right place. Let's hide the first sketch. Okay. Let's save there. Regenerate and save if it's annoying. Okay. All right. That's everything we need now. Let's make the tooth. So, swept blend tool. Choose this trajectory here. It's in the right direction. Make sure the purple arrow is pointing in the right direction. Constant normal direction to this plane. Sections. Let's sketch that first section. And let's project this profile into existence. Okay. Next, we are going to insert, sketch, and then we're going to put a point again at the end here and press OK. And there is our cone gear tooth geometry coming into existence. Excellent stuff. Now we want to pattern this, pattern around the correct geometry, the correct axis, I mean. Angular extent, important, press OK. And then we're going to set the pattern to a relation. At the bottom, enter, enter. Click on the pattern within the model tree, select the correct pattern, which is the one, again, that's connected by these lines between the first two components of the pattern, and equals Z2. Press OK, Control G, and just like that, we have the teeth of Gear 2. Okay. Now, next we need to remove the material we don't want from this. So I'm just going to orientate my view. We're going to revolve on this plane, and I want to reference this line, and we're going to just throw out a line like this. Press OK. The axis is our gear rotational axis here, and we want to remove material. Okay, again, you could change the direction of this, but obviously this is the right direction. Press OK. Excellent stuff. Let's save that for the moment. And now we basically just need to finish the rest of the geometry of this this part, the main body of this. So let's sketch. When it comes to when I set you an example, an exercise for this, I'll have actual dimensions for you. Right now, though, when it comes to the actual body of this gear, this is relatively arbitrary, really. So let's reference U and U, and the always hard to get to the the root line. Let's project the root line. Yes. Let's project U. Yes. And let's project U. Yes. Orientate the view. Get rid of this. Okay. And then I'm going to divide here. Let's divide there arbitrarily. Let's delete these. And then I'm just going to bring these through. And I'm actually going to have this floating this time round because I can. Connect. There we go. Let's have that angle. Let's have you being 10. Let's have you being 15. Yeah, 15. Let's have you as 30. Okay. Oh, did I not revolve that? Oh, lol. Okay. There we go. Revolve. And now we have our crown gear. Uh, this is quite deep, actually. Let's go back to that sketch. Let's change you to 5. Yeah, that's a bit better. Excellent. Save, regenerate, save. Well, there you have it. That's both of our gears. Uh, let's go. Pinion, yes. Crown gear, yes. Okay, excellent. So at this stage, let's go into the assembly and set up the animation. So, new part, assembly, uh, Spiral Bevel Gear, assembly L. Okay. Now remember, when it comes to assembling these gears, for bevel gears, we need to set the axes, the axes that both gear 1 and gear 2 are going to revolve around, and that connects the two. So let's do that quickly. There we go. We have two axes there at 90-degree angle to each other. And now let's assemble. Let's start with, where have I saved you? Let's start with the crown, I think. Yes, let's do the crown first. So I want to orientate this downwards, move you out of the way so I can see what I'm doing. Let's just toggle that off for the moment. And we're going to set a pin connection with the rotational axis of this gear to this central axis here. We're going to translate this with the, in this instance, the right plane to this plane here. We're then going to click rotational axis, and we're going to use here and here. And now this can obviously be rotated manually, but I'm just going to leave that for the moment there. Okay. And let's give you a new appearance. I want to have you look slightly more like metal. Next up, let's assemble the pinion gear. Okay. I'm just going to move this a bit more into position. We set the pin connection again. Make sure you're choosing the right axis here. It's the rotational axis for the gear. The translation is going to be the central plane in the center here. Okay, you see they connect automatically. We just now need to orientate them. But first, the rotational axis is going to be this plane. I think this is what the top plane with the overall model's assembly's top plane. And press OK. I'm going to change the appearance of this again as well. I'm just going to regenerate and save that for the moment. And then let's just hide everything. And let's drag these. There we go. To be in line with each other. Okay, and close. Excellent. Absolutely excellent. Okay, so again, very similar to the gear mechanism and motor and animation that we did for the previous gears, but let's go back into that now quickly. We go into applications, mechanisms, gears, we're going to click the pinion first. We could use the pitch circle diameter, but I'm actually just going to use the number of teeth. It does the same thing when you use the generic gear type. So that's 20 teeth for the pinion. And for gear 2, you have to select their respective pin icons here. It will be 40 teeth, apply, and press OK. The gear mechanism has worked, and you can tell that because you have these gear icons at these connection points here. And now if I drag components, you can see how the gear bevel, forgive me, I'm fumbling over my words there. You can see how these teeth mesh accurately and oh so satisfyingly. Okay, to finish off the lesson, let's just animate these correctly. So Control G. Let's set a servo motor to the pinion. Let's set this at 30 degrees. Angular velocity is the type. Enter. Press OK. Let's go into mech analysis. Let's set this at a frame rate of 30. And let's run that. Okay. Just for cleanliness' sake, I'm just going to go in and hide some of these sketches. I think that's fine. And let's do the same thing for our pinion. Otherwise, it's just really rather cluttered. Yeah, I think that's fine. That's fine. Okay. So we ran the mech analysis. So let's go into playbacks. Let's run that. Set the speed up to full. Get into a nice position here and press play. Okay, absolutely brilliant. Congratulations on completing this lesson, everybody. Just to summarize, in this project, we built a fully parametric spiral bevel gear system from scratch, explored the engineering principles behind spiral bevel gear geometry, implemented an unequal addendum system, and created a complete working assembly driven by parameters, relations, and equations. We've also seen how a relatively small number of design inputs can be used to drive an entire gear system and how those relationships can be leveraged to create intelligent models that automatically adapt as design requirements change. As always, I encourage you to experiment with the calculator spreadsheet and the model itself. Try changing the tooth counts, module, pressure angles, spiral angle, and so on. Observe how the geometry updates. Exploring these relationships is one of the best ways to deepen your understanding of both the engineering theory and the CAD workflows behind these gear systems. Okay, well, in the next lesson, we'll continue expanding our gear systems knowledge by looking at some more gear systems. I hope you're enjoying the gear systems module so far. Looking forward to seeing the next one. Thank you so much for watching and see you soon.